Alrighty, hosses, welcome back, and in this video I want to start talking to you guys about IP addresses. Now in the last video I told you guys how to use binary. It was actually a video from 2009, one of my earlier videos, one of the first ones I actually ever made. But the reason I told you guys about binary then is because you need to understand binary before you can really understand IP addresses. Now a couple key points before we begin is this. So in that last video we were demonstrating on an 8-bit system. In other words, we had 8 decimal places, 8 zeros or ones. Now we saw that with the 8-bit system, we can have 256 different values. So that's how many possible combinations of zeros and ones that you could have. Now a cool little formula for figuring out how many different values you can have depending on what bit system or how many places you have is this. If you take 2, wow, that was a horrible 2. If you take, 2, and you put it to the power of whatever bit system you have, such as 8, that's going to give you the amount of values. So in other words, let's say that you had a 32-bit system. So you had 32 ones and zeros. If you took 2 to the 32nd power, this is going to give you something like 4.3 billion. Now this is actually pretty important because later on we're going to see that an IP address is essentially like an ID number for your computer, and this means that we're limited to 4.3 different computers or devices that are allowed to be connected on the internet. And I'm going to show you guys exactly why this is a problem and how we get around it. It's actually pretty cool. But first I need to explain something else. Now let's forget about computers, let's forget about IP addresses and binary for just a second, because I want to explain how to send a letter through the mail. Now, I know people don't do this very often, but whenever you send a letter through the mail, you got to put a stamp on it, and then you write your return address right here, Bucky Roberts, New York, yada yada, and I don't know, let's say I'll send one to my friend in Texas. So I'll write his name, I don't know, like Tom Smith. And alright, whatever, Texas, you know, the zip code. Alright, so we have 2 different addresses that are needed whenever you want to send a letter. This is who I'm going to send it to, and this is my return address. And it works pretty efficiently because whenever we give it to the mail lady or the mail guy, she knows exactly where it's going and where it's coming from. And also, whenever Tom receives this letter, if he ever wants to send one back to me, all he has to do is he just looks at the return address. Now IP addresses are a lot like regular addresses, just for people for sending letters. They're used to identify each computer so that they can communicate. Where do you want to send the data? And whenever, let's say you're requesting some pictures from the server, whenever you get that data back, where is it supposed to send it? Simple enough. Now every single device that's connected to the internet is assigned an IP address. Now, like I said, an IP address, just like a regular address, this is just a way that we can identify each different device. Now, whenever I say device, I'm not just talking about, laptops and iPads. I mean routers, they have IP addresses. Every server has a unique IP address. So again, like I said, this is a way that we can identify which device we're trying to communicate with. Now whenever you see an IP address, and if you want to see your own, just go in Google and type in what's my IP and it's going to pop up. But you're going to notice that they're written in this weird format. It kind of looks like it's broken up into 4 different chunks. 1, 2, 3, 4. And these 4 different numbers are separated by dots. Now these different chunks, these different numbers, they're technically called octets, and they're broken up just so it makes it a little bit more readable instead of one long huge number. But essentially, what you can do is you can take this 32-bit IP address and you can convert it to its binary format. So each of these numbers can get translated into an 8-bit string. Now since we have 4 of them, that's why every single IP address is 32 bits. And there are some exceptions that I'm going to talk to you guys about later on why those are and what those exceptions are, all that fun stuff. But essentially, that's what an IP address is behind the scenes. It's a way to identify each device on the internet, and it gets translated directly to binary whenever computers actually want to send and receive data.